This video is going to be on graphing sine and cosine by hand, specifically looking only at the amplitude and the period, and that would also be known as like a vertical stretch, that's amplitude, or a horizontal stretch, that's period, or compression, you can squish them too. So that's what we're going to do today, is we're going to stretch vertically and horizontally, or compress vertically or horizontally. So first, if you look at the equation in the form where you can see the transformations, the number in the front is going to tell you the amplitude, or it's gonna tell you exactly what the amplitude is. The number here is going to help you find the period of the graph. And then the number inside the parentheses will tell you how far you're going to move to the left or right. If it's positive, you're moving to the left. If it's negative, you're moving to the right. The number on the end tells you if you're moving up or down, positive for up, negative for down. So the H and the K parts, we won't actually be dealing with those on this video. We'll just be looking at the amplitude and the period. So here is a normal sine graph. And whenever I graph these, I always remember that a typical graph has a period of 2 pi and an amplitude of 1. And when I graph sine, what I usually do is I put a point at my beginning and my end. So I begin at 0, 0, and I end where 2 pi hits the x-axis. And then in the middle, halfway in between, I hit 0 again. Halfway between the first 2 points, I go up to 1. Halfway between the second 2 points, I go down to -1. So up to 1 right there, down to -1 right there. And so I plot those 5 points first, and then I just connect them, and that's how I make my graph. So let's go ahead and graph y equals 2 sine 3 theta. So here's what I know about this graph. My period normally is 2 pi. The 3 in the front makes it look like my period should be like 3 times as long, but it's always kind of the opposite of what you would think. So just like on the transformations, how left is positive and right is negative, it's going to be the same thing with the period. When it looks like the period's getting bigger, it's actually getting smaller. When it looks like it's getting smaller, it's actually getting bigger. So I always just think opposite. So I'm going to take the period of 2 pi and I'm going to divide it by 3. So my new period is 2 pi thirds. That means that when I draw my graph, it's going to start at 0 and it's going to end at 2 pi thirds. The other thing that I know with the 2 in the front is that my amplitude is 2. So I have to be able to go up to 2 and down to -2 to draw my graph. So what I'm going to do is I'm just going to count out 8 boxes. I'll do my first 4 boxes as pi thirds, and then I'll do my second 4 boxes as 2 pi thirds. And I'm just doing that on purpose because it will be easier for me to graph. So the sine graph, it always starts at 0 and it ends at 0. So notice I'm ending at 2 pi thirds instead of ending at 2 pi, like a normal period. Halfway in between, it hits 0 again. Now's the part with my amplitude. So I'm going to go ahead and I'll just do this, go 2 boxes is 1, another 2 boxes is 2, -1, -2. And so in between my first 2 boxes, I'll go up to 2. In between my second 2 boxes, I'll go down to -2. And now these graphs look exactly the same, but because of the way I labeled my intervals, I've actually graphed both of them correctly. All right, let's try y equals -2 sine 4 theta. So on this one, the period is not 2 pi. It looks like the period is going to multiply by 4, but I always do the opposite of what I want to do. So I'm going to take 2 pi and I'm going to divide it by 4. And that can simplify. 2 over 4 is actually 1/2. So I'll go ahead and fix the 2 and fix the 4. So that's actually pi halves. So the whole graph is going to start and end from 0 to pi halves. My amplitude here is 2. And the negative in the front just tells me that instead of going up first, I'll go down first. So I want to set up my intervals so that they're easy to work with. So if you want, you could say like the first 4 boxes is pi fourths, and then the second 4 boxes could be pi halves. That would be fine, like that. Or if you wanted, you could just say the first 4 boxes are pi halves. And that, if you do it that way, you're just going to make yourself a smaller graph. So I'm going to go ahead and I'm going to make a smaller graph out of it. I'll leave that as pi halves. So if we remember from sine, we're going to go 0 is the first point. It's going to end at pi halves because that's the whole period. Halfway in between those points, it hits 0 again. And then I need to be able to do my amplitude of 2, so I'll go ahead and say, okay, 1, 2, -1, -2. So this first one, be careful because of that negative in the front. It means that instead of going up first, we're going to go down first. So I'll do my amplitude, I'll do down 2 first, and then up 2 second. And there's the curve. All right, let's try one where we have some fractions in there. Okay, so on this one, it looks like it's theta divided by 3, so you'd think, oh, the period's getting smaller. But no, it's actually doing the opposite. So for this one, I'm going to say my period is 2 pi times 3. So 2 pi times 3 would be 6 pi. And then my amplitude here is 1/2. So I know that I want to be able to get the whole picture in 6 pi. And you have options here. You could do each box equals 1 pi. You could do every 2 boxes equals 1 pi. It really does not matter. I'll go ahead and do every 2 boxes is 1 pi. So I'll do pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Didn't feel like writing all the numbers in there. All right, so sine. We can go ahead and label our y-axis. I guess I haven't really done that first. I'm going to go ahead and just do 1 and -1 on the ends like that. You could put 1/2 at the top and -1/2 at the bottom. It doesn't really matter. So again, remember that with sine, we start at 0 and end at 0. So I'll start here, end at 6 pi. Halfway in between, we hit 0 again. And then halfway in between those, it normally goes up to 1, but since the amplitude is 1/2, we'll go up to 1/2. So go up to 1/2, halfway in between those, go down to 1/2, and then we can draw our curve. Okay, now let's look at cos. So with cos, instead of starting at 0 and ending at 0 like sine does, we start at 1 and end at 1, but we're still doing 0 and 2 pi, so those numbers are still the same. Halfway in between those, we dip down to -1, and then halfway in between those, we hit 0. So when I graph these, that's the way I think of it, as graphing my 5 points. So let's go ahead and graph y equals negative cos, and we'll do theta divided by 4. All right, so a normal period is 2 pi. I'm going to do the opposite of what I want to do with the period. I'm going to multiply it by 4. 2 pi times 4 is 8 pi, so that's my new period. And my amplitude is just 1, like normal. It's got a flip though. All right, so my period is 8 pi. I'm going to go ahead and just say every box equals 1 pi. So I'm going to say 2 boxes is 2 pi, 4 pi, 6 pi, 8 pi. And my amplitude's 1, so I'll just say it goes up to 1, goes down to -1. All right, so normal cos graphs would start at +1 and end at +1. This graph has flipped upside down. So I'm going to start at -1 down here and end at -1 at the end of my period. And then in between those, they normally would go to -1. In this case, in between, it's going to go to +1. And then in between those points, it's going to cross over at 0. So cross at 0. All right, so I know the graph is going to come from up here, and then there's like a parabola shape. See the parabola? And then this is kind of like another parabola shape, and then like another parabola shape. So there's my cos graph. All right, let's say we have y equals 3 cos, and then let's say we have pi 4ths theta. This is kind of an interesting problem. So when we look at the period of the graph, 2 pi is a normal period. I'm going to do the opposite version of this. So I'm going to take 2 pi, I'm going to multiply it by 4 over pi. So I'm just doing the opposite of it like I've been doing every other time. If it was divided by 3, I multiplied by 3. If it was multiplied by 4, I divided by 4. So all I'm doing is the opposite of this. And so what's interesting about this one is you're actually going to have the pi's cancel out, and the period here is just going to be 8. So your answer is not going to have pi's in it. When you draw your x-axis, it's just going to be 1, 2, 3, 4 to 8. But it's still pretty easy to graph. And then our amplitude is going to be 1. So I'm going to go ahead and just say 1 box equals a whole number. So I'll count 4 boxes, put a 4, 4 more boxes, put an 8. And I lied about my amplitude of 1. That was bad math. Sorry, amplitude of 3. Okay, so I'll say each box equals 1, so I'll go from 4 to negative 4. So let's remember a regular coast graph usually starts up at 1 and ends up at 1. On this one, since we have an amplitude of 3, we're going to start at 3 at the beginning and end at 3. Halfway in between, we're going to go down to negative 3. Halfway in between those, we're going to hit 0. Oh gosh, that was terrible. So parabola, parabola, parabola. There's our shape.